Hi, I'm Chris Anderson at the EEWeb Tech Lab, and today I want to show you ZMDI's ZSPM15XX family of True-Digital PWM controllers for high current, non-isolated DC to DC step-down point-of-load converters. First, high current in this case means up to 40 amps, and the typical applications include devices such as servers, storage, routers, telecom switches, and cellular base stations. Non-isolated converters typically have a lower BOM cost and smaller footprint than an isolated converter. And in most point-of-load conversions, there's already been an isolated intermediate conversion. Point-of-load conversion distributes power to the system using that intermediate voltage, and then converts to the low voltage and high current output physically close to where the power will be consumed, by a processor or FPGA, for example. What makes the ZSPM15XX family unique in the market today is that it's one of the easiest digital power solutions to design in. The ZSPM15XX family is engineered to reduce time to market by simplifying the power supply design. To that end, the device is pre-programmed with the most common output voltages, eliminating the additional time to implement hardware or software programming. In addition, ZMDI provides recommended BOM and PCB layout, resulting in a nearly turnkey digital power solution with the highest efficiency and smallest footprint at an optimized cost. Although the ZSPM15XX family is pre-programmed, it still offers users flexibility to customize it to their application. With 2 external resistor strap pins, users are able to select output compensation, current limit, and output voltage ramp slew rate. The devices also integrate various protections and advanced digital control techniques, including ZMDI's state lock control, which uses 2 parallel compensation feedback loops, with one designed to improve steady-state performance and the other to improve transient response. To further boost efficiency and reduce time to market, the ZSPM15XX family has been optimized for use with ZMDI's ZSPM9000 family of Dr. Moss devices. For today's demo, I have the evaluation kit for the ZSPM15XX family. On the back of the evaluation board is the ZSPM1502, which produces a 1-volt output. On top, we have the ZSPM9060 Dr. Moss device, as well as the output inductor, some capacitors and headers and dip switches that are used to configure the board. The dip switches control the compensation loop parameters, as well as the output current limit. In this case, I'm currently configured for the 200 to 500 microfarad capacitance range, as well as the max current limit, which should be about 28 amps. These 2 headers, J1 and J2, configure the onboard transient load, which consists of a 0.1 and 0.2 ohm resistor in parallel. So with both of them selected and a 1-volt output, I should get about 15 amps. So I'll connect my oscilloscope to the output. So if I turn my power supply on, which is set to 12 volts, there's a couple things to notice. First, channel 3, which is the purple channel, is connected to the output of the timer for the transient load. And so I'm just using that to trigger the oscilloscope. The blue channel, which is channel 2, is the output of the supply. Now, my scale is set to 200 millivolts per division. And so at the transient load turn on, it drops about 200 millivolts and then comes back up, and it's about 20 microseconds before it recovers. And so you see that really fast response, but it's also a very controlled response. As you can see, there's not much overshoot. So if I turn this off and I switch it to a higher capacitance range, in this case, we'll go to the 2500 to 4000 microfarad range. So we're going to add a lot more output cap. And I turn my supply back on. Now you see, because of all that extra cap, that the supply doesn't dip very much, but it also doesn't have any overshoot either. Again, because the compensation loop parameters, which are all built into the ZSPM15XX, have been selected for the appropriate capacitance range. That's the ZSPM15XX family from ZMDI. It comes in a 4mm by 4mm QFN package, offering the highest energy density and smallest footprint. The simplification it presents to designers accelerates time to market while also providing a highly stable supply with a fast transient response in point-of-load applications. For more on the ZSPM family of controllers, visit zmdi.com.